quick and dirty. This is we're going to see where we're at today on the custom engine harness for this twin turbo 300ZX engine, VG30DETT. So this harness is not new. This is a factory harness that has been repaired and deepened in some spots and lengthened on some wiring and rerouted and shortened on much other wiring. Matter of fact, there's actually about 2 foot of harness that was removed from the back portion where it used to be bolted to the firewall. Now this is an engine assembly harness, so it stays on the engine. Comes out with the engine, goes in with the engine. So let's go ahead and kind of just recap where we're at. Some of this isn't done. I have to finish some of the terminal ends and replace some terminal fittings, but this is a test engine that's on the stand, and this is kind of the 3rd revision of this wiring harness. It continues to get neater and better every time. So the engine coolant temperature sensor and the temperature switch for the gauge are all routed underneath the engine cover. Now this cutout was here from a fuel line for nitrous that fed to the solenoids up front. So this cutout isn't really required. It fits underneath the harness if needed. But anyways, under the harness, let me get this out of the way. Basically the engine coolant temperature sensor and the temperature switch have been routed. The harness used to come over and go over across and go up and underneath with everything else. Along with the PTU harness was extended over, and the PTU bolts here. The PTU is rerouted over to the previous battery location. Or the harness can also be routed internally into the car if you want it in the floorboard with a computer. Anyways, I have 2 little brackets I've made that hold this down. I just have to drill and tap the intake for that, or revise it to fit other holes. The front 2 intake bolts and the back 2 intake bolts on this engine are missing. That's where I lift the engine from to install it. I have another harness I previously used on another engine, but that car actually got destroyed by a tow truck company. They dropped it off the side of their tow truck. So now this engine and a different harness is going to a different car, because now this is going to be a manual transmission car, not an automatic. Anyways, so this engine coolant temp and temperature switch route up the center now, along with the coils and injectors. Those are all rerouted. Most of those are not changed. Most of those not changed the length or anything. The length stays the same. It just gets new loom and new wrapping. The injector ends have been changed because this car has SARD 850cc injectors. The coil ends have been changed because they always crack. You know how it is. Excuse my crude duct taping, but that keeps anything out of the holes from the balance tube. So I have another bracket that I've made that I've got to finish attaching over on this side that holds the harness up. At this point, it's just got a zip tie holding it for mock-up purposes. I'll probably be done with this tonight and not make another video, so I'm going to go ahead and do it now before I get it in the car and try to explain it to you. I still have to do the wiring on the crank angle sensor. This harness is from a Series 1 crank angle sensor, like a 92 model car. The crank angle signal sensor is a late model crank angle sensor. So it has a rounded plug instead of a squared, and the wiring is different colors. There is a black with a white stripe and a thin black, which are the same as on the other plug. The difference is the 2 shielded wires to signal, and those are a green and yellow and green and black, I believe, and on the other harness they are a white and black, or black and with white tracer and a solid black one. I may be wrong, I don't remember. Anyway, so I got to figure out the routing on that to see if they're in the same location or if they've changed. I'm sure they're the same, but we'll check. Anyways, the harness, just a single piece of harness routes on the back. The factory bagging, I reused that for some of the heat retention. There's also some of the heat shielding that's underneath it to protect from the exhaust underneath. Then it comes up, you got your plug. This is one of your ground straps. It's actually going to retain some of the harness rigidity where it's at, along with the secondary ground strap in the back right here. And the main part of the harness right here is where 2 feet of it was removed. It was a huge wad of wiring. I counted, I think, 91 wires from the harness. And each one of those were cut and shortened about 2 feet and then soldered and heat shrunk, reconnected, except for the shielded ones, which I kind of rewrapped. you don't really want to cut shielded wires. That shielding is there, and each wire is wound a certain amount of times around each other per inch to cancel out interference. So each kind of electrical signal creates interference. So in order to you can either try to eliminate it through the system, which is very difficult, or just use a polar opposite interference, which will just cancel each other out. Then you won't be giving two wires interference to each other. Similar concept is why you don't run your power system for an amp right next to all the speaker wires. You get some interference. Anyway, so we've got the VTC solenoid and the oxygen sensor. Now those are, the VTC solenoid's been switched location. The shorter wire one is now on the passenger, or on the driver's side of the engine. The longer wire one's now on the passenger side. But that one, I shortened the harness, is a very short piece. Now this is kind of extra hanging here. I'm not done with that yet. This is extra as an aux sensor. I'm not done with that yet. Previous harness, somebody had cut this thing and spliced it with some cheesy butt connectors. No heat shrink, no solder. So we'll get rid of that. Already a hindsight scenario is I should have wrapped these two a little closer to the top and then exited this harness out the side here. So next revision, I'll take care of that. Of course, the other ground strap I was talking about that retains some of the harness onto the engine. Okay, I already went over oxygen strap. Okay, this one, the coil runs over the back for the back coil on the driver's side. The injector comes off the side here along with the air valve connector. Then over here, like I said, I'd like these to have been stuck more as well, and then them exit out the harness right here rather than back here. So they're exit out, and then injector and coil, and on and on and on and on and on, injectors and coils. Now the engine plug side of it is here. That goes over into the engine. I have to extend the white plug so I can get it back in accordingly. If you don't extend that or depin that connector, you cannot get it in the hole. No pun intended. Now the PTU, like I was talking about, actually if you use the factory length of that, you get, as you can see, if I get it connected, a rather long connection. This allows you to route it either inside the vehicle or over to the battery box or up in the front fender under the headlights or up under the driver's side fender under the headlight. Or if you want to mount it on top of the car, that gives you plenty of cable to do that. I retain the factory loop because that's actually a test loop for an amp clamp. So if you can retain stuff like that, you want to do that. That gives you the ability to still use the factory service manual and testing and troubleshooting guides to do your normal troubleshooting without having to back probe into wires or push into the front of connectors, which you never want to do when you test them. So that kind of overlays the wiring harness that's been changed here. Modification wise, it takes a lot of time to do that. I basically just take the factory harness and de-loom all of it. Just cut all the looming off to where all you have is just bare wire and connectors. Yes, this takes a long time. This probably takes from start to finish. Your first time, probably 15 to 20 hours. I've done like 7 or 8 of these now, each different engine configurations, different modifications, different deletes. And it takes me probably about 7 hours start to finish. Now you'll notice there are a lot of stuff I didn't go over. There's no EGR. That's been deleted. Now rather than just cut the wires and wrap them up in the harness somewhere, if you've got it all de-loomed, just go trace each wire all the way back to the ECU connector. So I can get this under control here. Pull these little wings back like that. If I can get my camera to focus, which it does not. And you will notice that you can, anyways, you can depin them. You can take the pins out of the harness. God, this thing will never focus. Anyways, you can simply take each wire out of the harness and depin it. You'll no longer have that wire anywhere in the harness. It's much cleaner. You don't have anything extra. There's no spare wires laying around inside the harness. That's the way to do it. Are there better ways of doing this wiring harness? Absolutely. There'll be 10,000 comments saying it looks like crap. Guess what? It's okay. They don't bother me. Anyways, that's kind of where we're at. This is, interesting project-wise, a non-turbo engine that's been converted to twin turbo, which if you watch any of my videos, you've seen many of these engines that I have built. It is essentially a non-turbo engine with turbo pistons and oil squirters and wrist pins. And that is about the only modification that's made. I usually retain non-turbo heads, lifters, valves, everything that's synonymous. I pull the engine apart, replace the pistons with twin turbo pistons and wrist pins and oil squirters, which essentially makes this a turbo engine. There's not much between that. There's not really any difference. The intakes are a different part number. They're slightly different. There are different provisions for vacuum ports on the sides on the turbo engine. Other differences are the heads. They're different castings. The horsepower ratings are nominally different. You'll never notice. They're almost identical. You can argue that all day long. By the time you're done modifying your vehicle, it will not have mattered. Is it more efficient to use turbo heads? Absolutely. Is it cheaper? No. You can get these dirt cheap. These are out of the 94 or 93 and up non-turbo cars. They're a good casting. They're the newer style injectors, newer style injector bouses that hold them, and they're cheap. They're from non-turbo cars. But I use the heads, I use everything else. Like I said, pistons, squirters, wrist pins, that's about all that gets changed. Then freshen up the build, new bearings, new rings of course, honing the block, boring if needed, aftermarket piston size of course if you got to bore it. You kind of go from there. Put all that together. I use a non-turbo computer. Because guess what? There is no difference between the two computers. The EEPROM is the only difference. Sans the wiring. I take that back. The fans, there are multiple fan speeds for the air conditioning on the Turbo Zs, and there are multiple speeds for the fuel pump controller on the Turbo Zs. On non-turbo, they're just single speed. Funny enough, if you use a non-turbo computer with a EEPROM program for a turbo car, you just retain the high speed. So yes, you're pumping some extra fuel through the rails when it's not needed and heating the fuel up. That's the math on why you shouldn't, why you should have multiple speeds and use that. And then same thing with cooling fan. You want more. The more variable speeds you can add, the more accurately you can control the temperature, and temperature rules the whole world of air fuel. So of course it is better. Does it work? This works absolutely fine. That's the long and the short of it. So from there, that's kind of what this is another non-turbo converted to twin turbo engine. I don't need boost cut solenoids because I don't want them. You delete them off of your turbo cars when you buy a factory turbo car. That's just like converting a non-turbo car to a non-turbo complete car to a turbo car. Usually that's in your best interest if you're going for a heavily modified Z, because you'll delete the HICUS. You'll want the 409 gear ratio instead of the 369 that's in the twin turbo. Then you'll have to change the power steering pump and the lines because you went to just a front wheel steering system, and on and on and on. And we end up deleting clutch bleed lines off of the turbo cars and all that. You know that. So that's kind of my reasoning of why I use non-turbo cars. I don't really keep any stock Zs. I like them modified a certain way, and it makes them easier to work on. This whole intake comes off in probably 25 minutes because there's no water pipes. There's nothing on there. So from that point, I mean, that's my reasoning for it. If you want a stock Z, buy a stock Turbo Z. It's much cheaper than buying a non-turbo and getting a front clip and changing all your factory stuff over. Anyways, that's where it's at. This motor and wiring harness will be going in that car. That is a 92, 91, I don't remember. Anyways, red, that's a native twin turbo manual car that came with twin turbo manual. There's the transmission out of it. There's the automatic transmission that came off of this motor. That's a fully built automatic. Not an auto tragic, it's an auto magic. It will shift faster and provide more horsepower and torque to the ground than what your manual ever could. Well, not more horsepower and torque. Of course, the manual is 99% efficient compared to losing about 20% of parasitic loss in a manual or in that automatic. But that one has a modified valve body and better quality clutches, and actually each forward gear clutch housing was machined to accept at least 2 more clutches and a thinner top plate. In each forward gear, reverse gear was left untouched. It does use the wider drum of the RO3A. It also uses the 4-gear planetary instead of the 3-gear planetary. So it is a significantly better quality transmission automatic-wise than what the stock one is. That transmission on this motor in that car will outrun this motor with that transmission every single day of the week. But this isn't a drag car. This is a daily driver car, so this will have a manual. It's more fun. That transmission is not fun to drive on the street. I had that transmission in my convertible, and well, it doesn't like to shift until about 4,500, 5,000 RPM, and it's pretty brutal when it shifts. Anyways, that's the overview of this wiring harness, so maybe more in the next video about it.